Today we are talking about push notifications. Things with push notifications have not been easy for many people who tried it out, and they not often work on the first try because there are so many little things. What I had planned to show you today is to go through pretty much every single step in the setup and the coding as far as the APIs are concerned, to demonstrate what it takes to configure an application both on Android and iOS in order to be able to subscribe, to receive push notifications and publish push notifications. For those who are not familiar with push notifications, the concept is very simple. Your mobile device can register with backendless and thus be able to receive notifications that arrive to your application, regardless whether the application is running and is on the forefront of the interface or is sitting somewhere in the backend. Background. And the concept is very powerful because user may use your app and then shut it down, turn it off, send it to the background, and then whenever you need to send something to that user, you can still do it and they will see that notification even if the application is not running. The concept of registering for or receiving push notifications consists of two steps. One is you have to register your device. If it is Android, you register it first with Google Cloud messaging servers, and then once it is registered, you get sort of a token back that is then registered with backendless. And with Google, it's done much simpler. There's just one call that takes care of that completely. And with iOS, it's somewhat similar. You register with Apple Push Notification Service, and then that registration is sort of passed on to backendless. It sounds more complex than it is. So let's start with the actual demo and see how that actually works. If you have any questions as I go that you wanted to find out and ask, even if it is not related to push notifications, please feel free to send your questions to the questions pod of GoToWebinar, and I'll be periodically checking to see if there are any questions that I can answer. So with all of that, let's start with Android first, because it is a bit simpler than iOS. So let's get this out of the way, and then we will be moving on to iOS. So let's just start a new project, and let's call it Push Demo. So here's the minimal SDK. Create a blank activity, and it's going to create a brand new project. All right. So here's our project, and in the manifest that is created, we will need to add permissions that we'll be granting to that application, and you can get the permissions from the documentation. In the documentation, if you go to the messaging section and then select setup, on that page for setup at the bottom, you will see the configuration for push notifications. So take all of this, all the permissions, copy them, and add them right there before the application tag. Also notice that there are two lines where app package name needs to be inserted. You can take this package name right there from the generated manifest and paste them into this placeholder in both of these places. So that's part number one. Part number two is to take the receiver. So you can just copy all of this XML and paste it into the application element. So here's our application element, and right here we can paste the receiver. So the receiver is there. There's also package name that needs to be copied over, so we'll do that. So here's the package name. Now notice that backendless broadcast receiver class, which is being referenced in this XML, is not recognized, and it is not recognized because the backendless dependency, the library, has not been brought into this project. What I usually do is I go into my configuration for the application, select dependencies, and in here bring in the dependency from Maven. So here you can just search for backendless, and here it is. Select the latest version, which is 3082 right now. Click OK, and now Gradle does its magic and recognizes the library, and then it's no longer red. So this has been configured. These are all the configurations. I know it seems like a lot, but they still are fairly straightforward. But these are all the configurations that you will need on the client side. Okay, there are two more things that we'll need to take care of. Before we do that, let me check what questions you guys might have. Okay, so no questions as of yet. So second thing that we will need to do is to configure the backend with Google API key and also get the GCM project ID. In order to do this, we will need to do the following. So we're going to go to Google Developer Console. And in Google Developer Console, let's just create a project. I was messing with it as I was preparing for the webinar, so I created one project, but we can create a separate project for this. So for this, go to Manage All Projects and create project from here. Webinar Push Demo. All right, now it's good. Click Create, and then the project is being created, and so things are still happening. And we should see it right here in the list at some point. There you go. So now this project Webinar Push Demo has been created, and it's very important to check that the messaging API is enabled. So click on Enable and Manage APIs. And here you just search for word messaging, and then Google Cloud Messaging is the one. Click on it and make sure to click Enable. So that enables Google's side of things, so the messages can start floating through Google into your devices from Backendless. All right, so now that is in there, you need to click go to Credentials and create the API key. So here on the as far as where it will be called from, it's going to be called from web servers. So it's going to be called from Backendless servers into Google Cloud Messaging to push messages. And for this, we can just take the server, take the name for the key the way they generate it. It's not very important. Click on Create API Key. So this API key right here, you will need to select, copy it, and then you will need to return to Backendless Console. And on Backendless Console, go to Manage, App Settings, and there is going to be a section called Mobile Settings. So here in the Mobile Settings for Google API Key, you need to paste that API key that was generated from Google and click Save. Okay, so now the backend side of things between Backendless and Google is configured. But we're not done with Google project yet. Here we need to return to our project. And right here, our project is Webinar Push Demo. This project number is important. And it is important for the reason that we will be using it to register our device with Google. And let me show you how that would work. So I'm returning back to my code in my activity. And we'll just use this onCreate callback for the application. Before you do anything else, it's very important that we call backendless.init app. Notice that there are two init app calls. One takes context and then application ID and secret key and version. The other one doesn't take context. So whenever you work on Android, you need to use the init app call that takes the context. It's very important you do that. And the context could be just your activity. And the second argument is going to be application ID, and we can take it from our application. And for this, I created a pre-created application called Webinar App. I'm going to copy application ID, and I'm going to take Android secret key, the second argument, and the third argument is going to be the version number. The default one is V1, and I haven't changed it for this app. So this registers application for Backendless on the client side. So after this is done, then we can proceed and register the device. And the device registration is just a one-liner. And for this, you do backend list.messaging register device. Notice that there are different register device signatures. The basic one is this register device GCM sender ID. However, we cannot use this one right from here. Notice that if we were to call it from this, we're still in the main UI thread. And then calling this method on the main UI thread will give us an exception. It will say, well, network communication is not good, so you will get an error. So it's very important to keep in mind that whenever you make any of the API calls on the main UI thread, use the asynchronous version for the API. And for this, it's going to be the first one. So the very first argument is going to be our project number from Google. So this guy. Returned to Google Developer Console and got the project number for the project that was created. So, and then the second argument is going to be the callback that we're going to get back whenever device registration it has succeeded. And in here, let's just acknowledge that device has been registered. And if there is an error, we're also going to put it into the log. Just save it. And we're going to say server reported an error and display with that error right here. This is it. So once this is done and once we run it, then the device where this application is running is going to be registered both with Google and with backend list. And at this point, it is ready and can start accepting push notifications into the device. Okay, I already had the emulator running right here, but to make sure that I avoid any kind of errors, I'm going to quit this emulator and then rerun this application. And we're going to launch a new emulator. Now, while it is starting, something else that I did in preparation for this webinar, I put together a Java program that we will use to demonstrate how notifications can be pushed to our app. So while it was starting, I think our app has timed out, or no, it actually is running. All right, and right here, if you noticed in the log, it says device has been registered. Okay, and on the server side, if we return to backend list console and switch to messaging, then in the devices tab, we see this Android device right here. Okay, so that's our device. And the reason device ID is unknown is because we started it from emulator, and in that case, device ID is not calculated. We do provide the API to register device ID, and in fact, let's clear all these out and override that in our application, just so we do have a device ID that will be used. And I believe that will look let's quickly check the source code for what the device ID is gonna setting it up, it will look like. It's messaging device ID. Okay. So here we could just give it really any ID. So device ID is not very critical what it is, as long as it is unique in the context of your testing. So whenever you test on the emulator, you can just use this logic to override the device ID. So now if we were to rerun this application, the device has been registered. If we go back to Management Console and refresh the screen, here it is. Here's our device, and it shows device ID emulator. Okay, so at this point, the device is ready to receive push notifications. And as far as publishing push notification, there are two options. You can publish it right from the console. In fact, let me set it up so you can see both console and the emulator. And right here, publishing to Android as well as iOS does require you to know special headers, which need to be included with the publication call. All the headers are documented in the docs. In fact, if you go to the messaging documentation and select Publish Push Notifications, you will see all these headers. So for Android, there are three headers. The Android ticker text header is will contain the value that will actually kind of scroll through real quick in the notification center when notification arrives. It's that text that you see at the very top that shows up briefly. The content title is the main title of the push notification in the notification center, and the content text is the actual body of the message. So here we will use all three and put them into headers. And this one we will call ticker text. Although I believe on the emulator, ticker text does not show up, but we will still use it out there. So then we will use content title. And let's call it urgent message. And finally, the content text. You received a push notification. It's a good idea once you, as you're testing, once you put all these values into here, to select it all and copy it into the clipboard so you can reuse it. Additionally, message text can be put in here, although that will not show up, but will be delivered to your device. So now we have configured everything, and we can just select deliver it to the Android devices. And notice if everything goes well, and at the top we should see a little icon when the push notification is delivered. Well, there you go. Now we have, here it is, the push notifications just arrived. So sometimes it's, keep in mind that with notifications, sometimes it really is just a matter of timing. So the way I believe Google and both Apple, they say that the delivery is not instantaneous, it may be scheduled. So depending how busy their servers are, this may happen. So the push notifications were working all along. They just arrived to us sometime after. So now I published it from console, and let me do it one more time just to change the text. Test message. Publish. So hopefully this will arrive shortly after or sometime into it, but they're definitely working. And one more time that I'm going to do is show you publishing that notification right from the standalone program. Let's review it one more time. So here, the process of publishing a push notification is quite straightforward. The most tedious thing is configuring those headers. So as far as the headers, the ones that are relevant to Android are right here. So we configure the Android ticker text, content title, and content text. Okay, and you set up those headers, and this is really nothing but a hash map. You put those headers into an object called publish options. Okay, and then publish options, it goes into the signature of the messaging.publish method. There is also another class called delivery options. Delivery options has various properties. In this case, the one that I'm using is called set push policy. And this one dictates whether the messages are going to be sent out as only as push notifications, which this only indicates. But there is also another one which is also, and what also implies is that it's going to be not only push notification, but also a publish subscribe message, because in backend there are two ways to broadcast messages. So here in this case, you take those publish options and delivery options, as well as the message that is being sent, and you put it into the publish call. And then if you run it, then this executes as a standalone program, although this could be an Android program. Then there you go. We have those notifications delivered to the device. Okay. Now the reason there are two notifications coming from here is because in console, if you look, I have two registrations for the same device. One with device ID, the other with without the device ID. So it actually, since it is going to be the same device that is connected, it's sending it out two notifications to that single device. Okay, so this is a demo of Android notifications, and I see there are some questions. Let me take a look at them. So that user says, about publishing notifications. I had similar issue when using backendless in debug mode with Android Studio, and it was a mixture of timing and emulator issues. On real devices, all went okay. Well, thanks for confirming this. This is really it could become a very frustrating thing where you publish a notification, you expect it to arrive, and then it arrives later. What happened? The webinar that I did last week, when I prepared everything and I had the whole thing set up ready for push notifications. I tried it out right before the webinar. Everything's working beautifully. I start demoing it and the notifications don't arrive. And it's quite frustrating whenever you're in a kind of a live environment. All the demos here are live and it's being recorded and it seems like nothing is working. I stop the webinar. It take about 20-25 minutes to answer all the questions. Stop the webinar, and then the moment, like 20 seconds later, all notifications arrive, and that was quite frustrating. So here, clearly, we see that, and there you go. You see the messages keep on arriving. Everything that I have sent so far is arriving. So we see that they are working. Okay, which is a good thing. I'll keep the simulator running, and I will switch to iOS, since this one is even more tedious. And hopefully we'll get to the same point where you can see notifications arriving to iOS as well. So as far as iOS, the biggest challenge that personally that I find is actually in configuring everything as far as those certificates, app IDs, provisioning profiles. There's a whole 9 yards of steps that you need to do. And Apple had simplified it somewhat, but I believe it is still fairly complex. Now, as far as the documentation is concerned, I went through everything that is documented right here, every single step before the demo, and it worked fine. So if you would like, for the just so this is recorded and one can go back and do the same thing, I'll go through the same process one more time. So this process starts with creating an app ID, okay? And for this, you go to your member center, and you have to have developer account, and click on certificates identifiers. So we're going to have select the identifier for the app ID, and then we're going to be creating a new app ID. We will give this the app ID description is going to be webinar. Let's just call it push webinar demo. Okay, and the app ID prefix, in my case, it was already pre-configured. We have this team ID that we use internally. I was trying to dig out the information of where this comes from and how it is configured. I believe it is related to provisioning profiles. I was not quite sure. So if you work with iOS, I assume you know what it is. If you don't, please post the question to our support forum. I will get the guys who know this for sure get this information, and you will be and we will answer this for you. So the next step is we're going to set up the bundle ID. The bundle ID is very important. So this must match whatever the bundle ID that you use on the client side. So here we will use com backendless push webinar demo. Okay, we need to remember this because the same bundle ID will need to be used in Xcode to configure the client side of things. Okay, in the app services, it's very important to enable push notifications. Okay, so this is, and all of this is step one. Okay, click continue, confirm that everything is the way you wanted it to be, and click done. Okay, so now our iOS app ID has been configured. Okay, let's validate it against the docs. We did all of this. Then the next thing is going to be creating a certificate request. For this, you need to open the keychain access application. And in here, you select request certificate from a certificate authority. Okay, then here I'm going to put my backendless.com email address, common name, and the CA email address, even though it says required, it is not required. You just keep it empty. And in fact, our documentation does talk about it. So here you fill out these two forms. This is you keep it as empty, and then you select save to disk, just like I have it here. Click continue, and we're going to save it to disk. I'm going to replace what I had, and this part is done. Okay, then the next step is going to be generating an SSL certificate. And for this, we'll return back to the Apple developer and then click on certificates. All right. And in the documentation, it says that we're just going to create a new certificate. Okay. So here we're going to click plus. And what certificate do we need? We need the Apple Push Notifications Service Sandbox. Okay, there are two types of push notification certificates you could generate. One is the Sandbox, and the other one is this Sandbox and Production. The way Backendless is implemented today is that if you use this, we will be hitting Apple Development Service, the Sandbox. If you deploy this certificate, we're going to be hitting their production boxes. We're working on a change where if you deploy this production certificate, you will get a toggle that you will be able to control whether it should go to Sandbox or production. But as of right now, just keep in mind that this is going to be development boxes, this is going to be production boxes. So we select this Apple Push Notification Service for Sandbox, click continue. Okay, and the app, we need to select our app ID, the one that I just created, and this is the Push Webinar Demo. Okay, click continue. Confirm the CSR, continue. So now we need to upload the file that we just created previously using Keychain Access. So this was downloaded to my, I believe, desktop. This is the guy created today. Click open, generate. So the certificate is ready. So once the certificate is ready, and let's just scroll to the dock, we need to download it. Click download. So here it is, our certificate is right here, and click done. Okay, so this was step 2. Then the next step is to bring that certificate into Keychain Access and then export it. So then we open the Keychain Access again, and this certificate that we downloaded, you can just call it development certificate. And I'm going to bring it right here. All right, so here it is. We have this development certificate for Push Webinar Demo. You notice that the bundle ID stays the same. And now we need to export it. And just remember the file name when you do that. Click Save. I already had this file. I'm going to replace it. And whenever you export it, you will need to assign a password. For the simplicity's sake, I'm going to keep password as the word password, but you can assign any password that you will remember. It's very important that you remember this. So click OK, and this is going to be my password for my computer. So now certificate has been exported. The whole reason you needed to do this is because we need to bring that certificate into Backendless now. So if you go to Manage and go to the same section where we imported Google API key, we need to do the same thing with our certificate that was generated to configure the Backendless backend with that certificate. So here I'm going to find that file that was generated. It was in downloads. Here it is. This is the file. Click open. It is uploaded, and the password, as I had it before, it is still password, and then click save. So this concludes the setup of Backendless backend with your certificate. So now Backendless can communicate to Apple using your certificate for the applications that will use the same certificate on the client side. So now we have a complete chain. It seems very complicated, especially in comparison to Google, where the number of steps was reduced by about 90%. But it's very important that all of these steps are done exactly as we describe in the documentation. And so at this point, it is good because we have everything set up. So now the question is, what is going on the client side? Do we need to configure Xcode? The simplest way that I found and granted that I'm not a professional user of or professional developer of in iOS. My specialty is elsewhere. So here I had to do a lot of sort of learning as I go, but I know enough to get myself into trouble. But the simplest way that I found to get things going with Xcode and push notifications is if you go to code generation, select iOS, and here select sample push. That will give you a project that is pre-configured and has enough code in there to actually see how push notifications are working. So click download project. That's going to give you a zip file that is generated and contains all the logic demonstrating how push notifications work. And this project is going to be pre-configured with everything that backendless requires. It is downloaded. I'm going to expand the zip file. And the zip file contains an Xcode project with all the code. So let's just open this one up. So this is the Xcode project. The very first thing that I would recommend that you do is select the root of this project in this project structure, and notice that the bundle identifier that is in here is different than the bundle ID that you configured your Apple side of things with. And this is going to be the same thing that you had in here whenever you went to app IDs. Okay, so the app ID that we had here was push webinar demo. So it needs to be this string, com backendless push webinar demo. Or in your case, whatever the ID that you chose to have for your app ID will need to match this bundle ID. Okay. Somehow it says that there are no matching provisioning profiles found. I think I have missed a step in the documentation. Let me double check. So let's select iOS. So here the Xcode setup. Yes, I believe I have missed a step. All right, so here to get this thing configured, we need to return to developer account and select under provisioning profiles. We need to create a provisioning profile that includes that app ID. For this, we select provisioning profiles right here, and let's create one for our application. So it's going to be iOS app development. We will select our app ID, which is webinar push webinar demo. This one. Okay, click continue, and that will be assigned to my account. Click continue, and this is going to be the phone that I have sitting right here, which I will be using. Okay, or you can select as many phones and devices that you want that you will be testing it on. And then profile name, I'm going to call it webinar demo profile. Generate. I can just download. Although downloading, I believe, is not required because now in Xcode, it's completely automatic. So now this provisioning profile is active. So if I redo this, it should be able to find it. Yeah, so now everything is good as far as Xcode is concerned. Let's take a look at the code. A couple of things that are important to keep in mind. In the app delegate, all the codes for setting up and configuring push notifications for your app are ready to go. You can just start using it right away. As far as running this code in emulator, whenever you use Xcode, push notifications do not work. So you have to use a physical device. And here I do have an iPhone that I'm going to be using. And for this, let me start QuickTime just so you can see my phone on the screen as well. And for this, I believe I need to select new movie recording. Hello guys, you can see me, but I'll be switching to my phone. here it is. You can see my device right here. And what I'm going to do is I will just run this application, and hopefully things will just work. Oh, I think it started the emulator, even though I think I have selected the device. Let me stop that real quick, because we don't need an emulator, but rather a device. So now let me rerun it on the device. So the app is running. It asks me if I can send push notifications. I grant that. And here, let's just send a notification from here. All right, there is a question if there is any history of the messages sent. No, there is no history of the messages sent. However, you can add custom business logic to the application that will be invoked every time when a message is sent. And in there, you can actually uh, get that message and save it in the persistent storage. And this will help you get a complete history of all the messages that are sent. Okay, so there's definitely a way to get that information. However, it is not done out of the box. There is a question whether I'm going to show you a user-to-user push. So user-to-user push is essentially a variation. Well, right now I cannot show you the push on iOS for the reason that my messages are not arriving for some reason. What I'm going to do is if this doesn't arrive, I'm going to get it. Oh, actually now it just arrived. So as you can see right here, a message hello just arrived. So let me type message test, send it, and hopefully it will show up. So it's some sort of delay with messages that I'm experiencing right now, where I guess they're clearly not real time. So the concept is, as you can see right here, there you go. So now a bunch of messages started arriving. Now, if I were to put this application on the background, well, but right now that may not work very well, because this assumes that I'm, and here it is. You can see those notifications are showing up at the top. So messages are arriving, and here it is. You can probably hear my device buzzing, but they're all arriving. And if I were to scroll this down, so this is my notification center, and there is a bunch of messages there. So everything was actually working, and there is an even badge update on the device, but they were not arriving right away. So this demonstrates the messaging for iOS. Now let's go back to the question of user-to-user messaging. This can be configured in the API. The way you would configure it is in the delivery options. Take a look. And by the way, the API in iOS is going to be identical to the API in Java. So here you can configure set push single cast method, which accepts a collection of string values. So in order to deliver a message to a specific user, you would create a collection of their device IDs, and then put them into the set push single cast. And this will target specific users that will be receiving that notification. So this is how user-to-user push notifications would work. Okay, an alternative to that would be pub/sub messaging that you could implement, but that works only whenever application is being active. Okay, so that hopefully that answers the question for you as far as the user-to-user messaging. Okay, see there is another question. There is a question, how do you target a specific channel? That's an excellent question. So here in the publish API, let's take a look at the signatures that you have, and they are going to be the same. You have signatures that allow you to specify the channel name. If the channel name is not specified, it goes to the default channel. And the same thing on the device registration side. If you want to target a specific channel, then you identify that channel right here in the signature, and then all the same arguments, they do apply. This is identical to the device registration. So let's say in Xcode, there is going to be device registration somewhere here. Let me find if I can find that call to register the device. It's got to be right here. See, this is the device registration. So there is going to be a similar signature where you pass in the channel name in the device registration. Okay, so this is the callback that we receive from operating system when it is registered with Apple, and then we get the device token and then send it to backendless with this call to register with backendless. But in the same call that will have slightly different signature, you can also specify the channel name. And that's how you would register for a specific channel. It's almost identical on the Java side. So here, if we take a look at Android Studio, we use the call register device, and there's going to be a similar signature that takes the channel collection of channels here. So you pass in GCM sender ID, collection of channels, and expiration. Okay. Or here's there's GCM sender ID and a single channel. Okay, so that's right there. There was another question. Let's take a look. How do you get other users' device ID? This is a great question that comes up rather frequently. The way we recommend doing this is a device ID is attached to a device. Okay, the concept of attaching it to a user would come from your application. So one thing that you can do is if you have a logged in user and then you register a device, then once the device ID, once you register the device, in this case, the signature is not entirely correct. Once you register, the way this is supposed to work, and I would need to look into this further. Oh, I'm sorry about that. So there is a separate call, backendless messaging get device registration. Okay, so the get device registration gives you device registration object, which contains device ID. Okay, and it's the same thing on all operating systems, both iOS and Java. Then here you get the device ID, and you can map this device ID or really put it as a property into the user object and save that user object. So this way, all the users in your application that have registered for which the device has been registered, you will have their device ID. So that's how you can target them in your application. Okay, let's see. Can we send it to Windows Phone? Yes, there is support for Windows Phone. I have not planned to demonstrate it today, but the concept would be exactly the same. So the short answer is yes, you can send it to Windows Phone. Okay. All right. This is pretty much it that I have. By the way, these are additional notifications that were delivered to Android. Okay, so this is pretty much everything that I have planned to demonstrate to you. Sorry that some things did not work right away. There was a significant delay, and it looks like it was caused either by Apple or Google because eventually the messages came in. But hopefully this was useful for you as a demonstration for how to configure push notifications for Android and iOS. If you have any additional questions, I'll be more than happy to answer them for you. So the question on the device ID, whether you should keep it in the user table. Yes, I believe that would be the simplest. Is if you have it as a custom property for the user object, and then once you persist that user object, it will end up in the users table as one of the columns and thus properties associated with that user. Can we send push using REST API? Absolutely, yes you can. In fact, in the documentation, if you look under messaging and select REST, then message publishing is available from REST. So you can publish messages and you can publish push notifications. See, this is where all the headers go from REST API. Thus, really from any language that where you can create an HTTP request. As far as subscribing to receive, that's not going to be as straightforward for the reason that you have to interact with either Google, Apple, or Microsoft servers. Okay, I create a channel for each user using the user ID, then send user-to-user push notifications based on that. Is this okay, or do you foresee issues? I really don't foresee any issues because in Backendless you can create really an infinite number of channels. Using that to locate the user that you want to communicate to, it's fine. However, I think either using that or using the single cost option is going to be about the same. So I don't really foresee any issues. In fact, this is kind of a crafty way to do this. So uh, the only thing that might get a little bit challenging with the approach where you create a channel for each user is that if you anticipate a huge growth for your application, or you have hundreds of thousands or millions of users, then you will have literally millions of messages in your application. And locating the right channel and just doing some kind of maintenance where if you need to delete a channel in your application, then finding one in backendless console may be troublesome because there is really no simple way to locate the channel. So that would probably be the only concern that I have as far as doing point-to-point communication via channels. Other than that, it should be fairly straightforward. Okay, let's see. There is a question that is not really related to push notifications, but still it's a question regarding user logout in iOS. The current user doesn't get set to nil. I know there are several tickets that were reported through support that we created internal trouble tickets in our internal system that are being worked on. Some of them are going to be pushed out in the release that we had planned for tomorrow. I'm not sure if it's going to slip or not. Looks like things should go as planned, but we are aware of all the problems that were reported through support, and we try to react as fast as we can. So that's going to be taken care of. Okay, another question. When we log in with Facebook, it registers automatically to user table. Yes, whenever you log in with Facebook, you end up with a backendless user object that represents that social user, and there's going to be a record in the users table for that user that logged in through Facebook. So that's that. Your understanding is correct. Can we use Swift 2 for push or Objective-C? Yes, absolutely. For sending out push notifications, the project that I downloaded right here, it includes the push functionality. So right here, as you can see, whenever you type a message right here and press enter, okay, or go, a message goes out and it uses the publishing functionality from Objective-C. So in this case, in the code that you will find right here, there is going to be a code that takes care of message publishing. You will find it right here. Whether you can do it in Swift, absolutely you can, because we don't really have a separate Swift library. Our Swift is done through the bridging header. So everything that our Objective-C library can do, you can do also in Swift. In fact, this is the publishing API in Objective-C. We are in the process of updating our documentation to include Swift APIs, signatures, and examples. We have gone through user service, data service, and right now we're working on messaging service, exactly the functionality that I was demonstrating today. So as we progress, and hopefully by the end of this week, we will start publishing messaging updates to the messaging docs that includes Swift, signatures, and examples. So that is definitely very high on our list of priorities. Question. Will the auto code generation in backendless be available in Swift? Absolutely. We do have significant plans for code generation in general. To give you an idea of what my vision for this is, if you look in the marketplace, there is a area that is fairly hidden, that for the reason that it's just empty. But notice that right here it says client code generators. So my vision is we will open up and publish our framework for code generation for anyone to contribute to. We will create some basic code generators for various languages, as we have already done. But the idea is that if you know a language, or if you would like to contribute to Backendless and really make money with Backendless, you will be able to create your code generator, publish it into our marketplace, name your price, and if people like it, they will start buying it, and you will get the payment minus our commission, which is not significant. I believe it is quite reasonable. So this way, you can start enriching backendless and helping others to get those code generators. So, and then the idea will be you click on code generators, you install a code generator, and then you go to code generation section, and they will just start automatically showing up here. For Swift, here there's going to be like a drop down that you select, and you'll be able to use it right in your application. So that's my vision. How far we are from this? Not very far. We're working very hard to start utilizing our marketplace to the fullest. And the general infrastructure is there, so it really is just a matter to start populating it with content, services, and code generators. Right? So these are all the questions that I have. I'm going to start wrapping up now. So if you guys have any more questions, you can either send them to me directly or post them to the support forum. Thank you very much for attending the webinar. I do hope you found it useful. And the next one is going to be Friday this week. We'll be talking about data persistence. I highly recommend joining this webinar, especially if you're coming from parse development. Or if you're not, that's fine. We'll be doing an in-depth look into how persistence works in Backendless. Thank you, and I'll see you at the next webinar. Bye.